I'm going to get started. Alright, so last time we were talking about the origins of philosophy, which is where we'll continue here today. And so we start off in ancient Greece, studying philosophy. There appeared to have been huge new movements in philosophy in both ancient India and ancient Greece right around the same time. And almost in similar ways. There's a philosopher named Parmenides we're going to study here in a little bit. He asserted that reality involves nothing that changes. If it's just one big block of existence with no features. Obviously that violates your perception of the world. It comes in conflict with your perception of things. But he was a very widely discussed philosopher back then in ancient Greece. And in India, the concept of Brahman just across the bay there in India, that was a very, very similar concept. Alright, so let's just start with these notes here. Let's start talking about this. Okay, so here's how your reading assignments go. In this book here you go. So in the ancient philosophy book, I'll give you a reading assignment all semester. His name's Kenny. And the last name is Kenny. Pages 2 through 5, we talk about that philosopher. And then when we get a little further, then there's another assignment talking about the next one. It'll kind of work that way all semester. But again, the quiz is only over these notes. The notes based on the books. But quiz material is out of here. Okay, because the notes are fuller and more bite-sized in ways, and my opinion, people work a little bit better. So, all right, so we got this shift, which happened, which I won't say specifically what, since two people are still taking the quiz, but all of you remember. And that shift was first noticed with a philosopher named Thales. Okay, where instead of talking about reality in the old way that it was, he said something different, which all of you will find absurd, but the point is that it's very different. He said that reality is not composed of the old stuff that people used to talk about, but rather reality is composed of water. Everything's made of water. So if you can cut apart this piece of chalk enough, you'll find the little pieces it's made up of are little pieces of water. Apparently that's what he was saying, I guess. So obviously this sounds ridiculous to all of you, because and it does to some of the other Greek philosophers after Thales. But the point is that it's a new way of thinking, all of a sudden. Radically new. From what we can tell, people weren't discussing things in that way before. They were instead discussing ways in the previous way as we discussed last class. Now, so despite the fact that what you see around you, solid matter, all these items are actually made of water. Alright? So regardless of whether or not Thales was right or wrong, the point is that he went beyond the old way of thinking into a more analytic way of creating theory. That's, our opinion. Yeah?
Well, it says that it's like, it doesn't matter if he was right or wrong, but how did he get that?
Nobody knows. Because we only have 2 sentences from him. We don't have, it's not like Thales' book, that he wrote or something. A lot of these early philosophers from Greece, the pre-Socratic, these are all called the pre-Socratic. That means just before Socrates, who we'll be studying starting next week, I think. We'll get there next week. we just have little pieces like Socrates. Well, Plato will throw something in one of his books about the pre-Socratics, and Aristotle will. So people later on wrote about these people, and that's how we know about them. So we just have little bits. So nobody knows how we got to that point. There's really no, in my opinion, there's not a whole point in debating it because, I mean, we've got so little information. You know, anything could, you know, you could say, oh, notice the body's made of 7 or 80% water, so therefore everything must be, but it doesn't look like it is. It looks solid, but it's really, you know, so who knows? You know, you could come up with a zillion speculations. It appears to be the case that he's incorrect also. Seems everything's made up of energy. That's at least what modern day science is coming to. Yeah. So Thales was more interested in nature rather than the supernatural. He was more interested in the observable and physical reality rather than a reality of unseen supernatural items, as we discussed last time. So here are those two quotes we have, which are given in your textbook on page 4. So we said that water is the first principle of everything. In ancient Greek, first principle sort of meant, you know, what everything's made up of. Pretty soon, not very far down these notes, we'll be calling the first principle atoms, or basic building blocks, and we'll use those terms all semester. One of those terms is still used in science. This term is often used in philosophy. Okay, so in the other principle, the other statement we have from Thales is he said all things are full of gods. That sounds a little bit like the old way of thinking. But this, we've got this new statement here. So that's what's sort of new. So if you combine the two statements, then it's possible that what he's saying is that, you know, everything is composed of some kind of holy water or something. I don't know if it's fair game to combine those or not. These could be just real teeny little bits of a much larger story that this philosopher and some of the other pre-Socratics gave. It's just nobody really knows because we weren't back there. It'd be frustrating if you were a philosopher specializing in study of these people because you've got so little to work from. You know, in some cases, some pre-Socratics, you have 60 statements or 150 or something, but Thales you only have 2. You know, they're very open-ended statements, but if you want to try to interpret them, maybe if you did as literally as possible, it would be as if saying, you know, inside of everything is some sort of divine water or something. So, yeah, so you wonder, you know, you can make up little games to try to figure out what he was talking about. You know, does he mean that everything is crystal-like or water-like or something, you know, who knows? Almost impossible to tell. So, I'm going to skip, so I'm just going to cover these 2 paragraphs here and the 2 statements, then I'm going to move down to the next philosopher. Anybody have any questions over Thales? We'll kind of go through some of these first ones quickly, until we get some of the more significant philosophers like Heraclitus and Parmenides and Plato, Socrates, Pythagoras. Nobody? Okay. So another pre-Socratic philosopher, this one's discussed in your textbook on pages 5 to 8. He did not like what Socrates, Thales had to say. He thought that he thought it was hard to understand how the fundamental level, you know, how you could have something like dry dust composed ultimately of water. You know, how if there's something completely dry, how could it be made of water? So it's a very simple, good objection. So again, this is sort of a new way of thinking. And again, just to remind all of you that if you want these notes that I go from, they're on C-Tools. If anybody's having trouble, the other critical thing is that I teach you, they were having trouble getting to them. But if you have trouble, let me know. But if you want them, they're there, and I'll remind you that periodically through the semester. But I have no obligation. They're just the notes I go from. So, yeah. So here's how could something only composed? That's not a statement from Anaximander. That's just what Anaximander how could something with only wetness compose something involving only dryness? It seems that's impossible. Okay? So Anaximander was troubled by how whatever the first principle of things, and whatever the basic element that composes everything, the basic building blocks of reality, he was troubled by how they can be, how atoms can, okay, what am I trying to say? So let me just read through this, I'm trying to think. So Anaximander was troubled by how atoms cannot compose items that contradict atoms. So in other words, if you've got an atom, here's what we're going to be getting at. If you've got an atom which has a certain nature, call it N, and the stuff that it composes, stuff atoms compose, have a nature which is the opposite of that, not N. Well, how can something that has a certain nature compose something that is absolutely devoid of that nature? Okay? Turns out this is a very, everybody understand what I'm saying? This is in the, we'll go over this again in a second, but everybody got me right here now? It's the same thing says, the criticism that Anaximander and other philosophers have for Thales. You know, if there's, say the basic building blocks, the fundamental stuff that makes up everything is watery, well, what about perfectly dry stuff? So, but believe it or not, the same problem exists today in modern science, contemporary science. In other words, if you have, in contemporary science, and this is going to be in your notes in just a second here, in contemporary science, we're told that everything is made up of particles, and their basic nature, they have certain qualities, such as they flash in and out of existence, they are composed of energy, they have no material qualities. That's curious. So in other words, let me back up what I'm saying here, and again, we'll see this again in the notes in a second. In the present day, scientists tell us that everything is composed of tiny building blocks of little particles. Okay? So if you can break down a piece of chalk as small as possible, you reach a level where you've got some tiny little items that can't be broken down any further. You can call those atoms or particles or whatever. We'll get some specific names later. But the point is that they have certain qualities. Here's 3 of them. And they supposedly make up, such particles supposedly compose physical reality, like this, like you see all around you. Okay? Well, do you see the problem here? How can something with no material qualities make up stuff that has only material qualities? Exact same problem. All right? Which we'll be talking about here in a second. Yeah?
Never mind.
Is that what you're going to say? Yeah, good. I'm not just making this up. This is a real present-day mystery, which we'll discuss numerous times this semester. Go ask your chemistry professor. Say, hey, how do these little weird energy things, fuzzy energy, whatever, it's called atoms or particles or whatever, how they compose all this solid stuff? And they'll say, we don't know either. You know, that's a big mystery. And philosophers and scientists and mathematicians have been fighting about that for a long time. So here's where it emerges, right here. And the second philosopher we studied this semester named Anaximander from ancient Greece. What were his years again? Well, they're in the book. Sorry, I don't have his years that he was around here. I don't have them off the top of my head. Yeah?
What exactly are they fighting about? Are they fighting about, like, do some people actually think that something with no material qualities can make something with
Some people think that,
or
yeah.
do some people think the particles do have material qualities? Like, what exactly are they fighting about?
I think there's 3 options. One, and this probably isn't enough, but it's a good question. So, one is that what we just said over there, non-physical. You don't have to write this down. We're just chatting here. Non-physical basic building blocks compose physical, number of, especially scientists. Everybody know what a physicist is? You don't need to get all scared. We're not going to be studying math and stuff. Or like a quantum physicist. This is a term you'll hear all semester. You see, philosophy, we study the little teeny stuff that makes up everything, the basic building blocks. And in science, they do too. And the group in science that studies those, they're called quantum physicists. All right? So it's real simple. You'll hear that. We'll talk about that group all semester long. Okay, primary philosophical issues come from them. So the next option is that, okay, see, this is the group that's discovered that the tiny little building blocks that make up everything don't have physical qualities. But hey, what if they're wrong? What if they are just getting a partial view, and in time, in 100 years or something, with better measurements and analysis, we'll find out, no, that's not the case. So physical, we'll find out that the little teeny building blocks that make up everything, they actually are just like physical stuff, except much, much smaller. So physical atoms, or basic building blocks, promotes physical reality. That's option 2. And again, there's a big evidence problem with this one. Okay, right there, because that is speculative, because the evidence points towards basic building blocks not having physical qualities, which we'll talk about many times. The third option is to say physical reality doesn't exist. It's some sort of a dream or simulation or something. You're actually not experiencing all this stuff right here. You are, but it's not real. Okay, so why do we come to this conclusion? Well, because this is a big mess. This is the one that looks like it's correct, but how do non-physical things make up physical reality? That seems to be that's what science points directly towards. How? Because you can see physical reality around you. You can feel it. You've got evidence that it's real. And if you go study with these people in the physics department, you can all get a degree in that and study with them, you'll find out what they've discovered quite clearly is that the little teeny building blocks that make up all the physical stuff aren't physical. So reality is a contradiction. And if reality is a contradiction, well, then that leads right to reality can't be a contradiction. Contradictions don't exist. Contradiction will be something like saying that you are standing up and not standing up at the same time. That doesn't make any sense. Yeah?
Isn't it very non-physical?
Oh, well, sure. This down here, this could be any number of scenarios. I mean, if mind is not physical, if some people think it's physical, that just, to answer, if this was the correct theory, this is the one I actually might hold myself, not sure though, then you'd have to find out what the mind is. Go ahead.
But if the dream is not physical, then it will be creating a physical reality though.
Or it's just creating a set of images in your mind that you think are about a world out there, but it's really you're just locked in your mind. So it's just you're in a non-physical mind screen. You're existing in. And you think it's all real, but it's really not there.
So it's a non-reality creating a non-reality?
No, a mental reality creating a non-reality, which is what a simulation is called in some cases. There's a philosopher we're going to study called Plato, who seems to be, the adjective is platonic, that's what I'm going to do that. He holds a view very much like this, which is he's one of my favorite philosophers, that's why I tend to lean towards that one. But this is actually the one I think most people lean towards, most professional scientists. Why? Well, it's not because of evidence, because this one doesn't make any sense, and this one's too spooky. So most people go here, but the problem is that this is the one that has no evidence for it. It specifically has evidence that contradicts it. Okay, so there's that seems to be the three options. Make sense?
Yeah.
Cool. Good. Yeah.
If it's not made of material, how do we know the mass of like electrons and protons?
Well, mass is just a kind of motion and interaction with that's like a big thing in the news last year, the Higgs particle, which is really not a particle, it's like a field. What's a field? Imagine, okay, here's what mass is. If this is a particle and it's moving through the cosmos, wherever, in this room or in space or whatever. And it's moving through another field called the Higgs field, which was in the news. And it's just sort of like a glue that will slow it down or make it move in various ways. And that movement, that's what we call weight or mass. So mass is, we usually think of mass as like, you know, something, yeah, like it is matter, like it's some, like big hunks of stuff. But no, all those, it's like if you have a brick and you drop it, and it'll go thud on the ground. That's just, that's what its mass is. It's motion like that. The gravitational attraction brings it down to Earth. If you have, but if I was holding a small black hole the size of this, it would, everyone knows what a black hole is. Just think of it as a really, really heavy thing. The heaviest stuff there is. Most massive, which has the most compact mass. If I dropped it, it wouldn't thud on the ground. It would just shoot right through the floor and go to the center of the Earth. So that's a different kind of motion because it's heavy. We call it heavier. So it's different kinds of motion.
Could our view of science just be wrong?
Oh, of course.
Then,
of course. That's like the theme of my whole critical thinking class.
Maybe things like can be made out of no material?
Oh, yeah, yeah. It could be that all those three options over there are just based on, in 100 years people could be laughing at us. Because that's really what, those are the really views that people, number 3 philosophers talk about a lot, some scientists, but 1 and 2 is heavily debated by science and philosophers. Those could all just be the product of that we don't have precise measurements. We need better stuff to measure the little things that make up everything. And it could be, all this could just be confusion. And my gut is that it's not the case because some things we're discovering some pretty precise stuff. We don't know what these particles are, but we know some of the things they do, and they're weird. They act like non-physical things. I mean, they're doing some things that are impossible for physical things to do, which we'll talk about later. Just remember I said that. We'll get to that later. And when we go through some of those experiments, you'll see that, oh yeah, even if our views are all skewed, it still seems that the little building blocks have to be, they don't obey physical laws. And what are physical laws? Those are just all the laws you're familiar with, you know. Does the chalk pop in and out of existence here and then show up over there all of a sudden? No. Because physical laws require it to travel over there. It has to start at a starting point and then end at a destination. It has to cover every location possible in between. So that's a physical law. A non-physical law would be the opposite of that, where something can move from here to there by flashing out of existence, for example. You know, so, yeah.
That law is just based on my understanding right now.
Exactly, yeah. So what's your name?
Alia.
That's what Ali was saying, yeah. Just, it could be that, because I mean, when we study science, you know, there will be a perspective, you know, Big Bang Theory. There's a view that everybody and their plumber seems to hold these days. But it could be that in 100 years, that view is just seen to be just a stepping stone to a more accurate view. So that could be what's going on here with a lot of this stuff we're talking about, basic building blocks. Absolutely. Anyone else? All right. So there's the deal. It seems like some of you are understanding this quite well. Here's the problem which Anaximander brings up. Well, we're kind of describing it in a little bit better detail for him. But it's a problem which is directly relevant to science today to understate the issue. So Anaximander was troubled by how the little fundamental stuff cannot compose items that contradict that little stuff, like we were discussing here. Okay? Anaximander called the fundamental things, yeah, so he made up a new name for whatever the fundamental level of reality is that makes of everything. He called it a apeiron. Okay, some people pronounce this different ways. I'm just going to say apeiron. Okay, and what he meant by that is it's like a, well, some things in reality have only certain types of properties, but a apeiron, being only one thing, can only have one nature to it. It can be either wet or dry, not both. This leads to scenarios where wet things are made of dry apeiron, or dry things are made of wet apeiron. In other words, what Anaximander is saying is apeiron is magical. Okay? That's really what. Okay, let me back up here. So Thales tells us that reality is made, the fundamental principle, what makes up everything is watery or water. And then Anaximander comes along and says, no, that doesn't make sense. It has to be some magical substance. And he's got a really good reason for saying that. If you have, atoms, presumably the fundamental stuff, which makes up everything. Fundamental stuff, what's called stuff, for instance. There's a couple different names shooting around about that. It has to have a certain nature, right? Just call that N. But there's going to be stuff in reality it composes that's going to have the properties of not N, the opposite. Okay? So therefore, we have to avoid that issue, and we have to say, okay, the nature of Apeiron can't, it has to be both N and not N. But that's, let me explain why that's a big problem. Because these contradict. You can't say something is both N and, did we think of logic? No? Okay. Critical thinking? Alright. Yeah, okay. So N and not N. Okay? So just plug in some values for this. Let's say N equals sun is round. Sun is round. So the sun is round, and not the case that the sun is round. See the problem? That doesn't make any sense. It's called a contradiction, like we're discussing over there. So what Anaximander is trying to say, and that's why the reason the word magical is the fundamental stuff, Apeiron, is a contradiction. And so in order for it to exist, it has to be something completely different than anything any of you have ever understood. Because the laws of nature, which all of you are familiar with, don't involve contradictions. Okay? So if something exists that does obey, or does exist according to contradiction, which most philosophers on planet Earth would say that is impossible, then it's the case that the stuff has to be completely foreign to anything that you've ever conceptualized. In other words, it's magical stuff. It breaks all the laws of nature and so forth. Now, some of you are like, yeah, well, this is really dumb. This doesn't make any sense. Well, maybe, but when we study, we're going to have numerous times this semester this will come up. This group of scientists who study the basic building blocks of reality, the stuff that makes up everything in this room, including your body and so forth. Those do sort of act, I don't know, those basic building blocks seem to be filled with paradox, almost to the point of exhibiting contradiction. So while this may sound ridiculous, what Anaximander is saying, science has not necessarily shown it to be ridiculous. All right, scientists don't really know what to do about the basic building blocks of reality because they indeed don't make any sense. All right, so it's interesting that this chap Anaximander, whether it was by accident or not, sort of was discussing some of the same things. Okay, so he was sort of a early stage of quantum physics, perhaps. You know, maybe that's maybe it was just a coincidence, though. Okay, so anybody have any questions over anything we've discussed so far? I'm going to discuss this a little bit more. Everybody understands this perfectly? Okay, if you don't, let me know, because very well you could, have a quiz over it or something. So, but this describes it in more detail here in these notes. In other words, the problem is this: if some items in reality have only a certain nature, call it N, like we were just describing, but where the stuff makes up have the opposite, then we're left with the paradox. N is made up of not N. Okay, same thing we were just saying. So now notice something here. Okay, this paradox, very clearly stated right here, which is what Anaximander was concerned with, is analogous to these paradoxes. Why would I go out of my way to list some other paradoxes that are just similar like this? Because these are the modern day ones. Okay, these are the ones that quantum physicists have run into. All right? And, yeah.
Wouldn't they just cancel each other out, kind of?
Wouldn't what cancel each other out?
Items that are made up of N and not N, you know what I mean?
Oh, no, because we're talking about two different levels of reality. Teeny level, big level.
Okay.
So that would be like saying your body cancels out atoms. I think you're thinking more like two numbers.
Right.
or the negative 3 can cancel out the positive. Mix those two and you get nothing. But those would be on the same, those are integers, both in the same dimension, so to speak, the dimension of integers. But you're talking about different dimensions here. You're talking about the micro, the quantum dimension, and then what we call the macro, what we can see. Yes?
This might be a stretch, but like electrons and protons, like one's negative and one's positive, and they're both in the same thing. So couldn't that kind of be like N and not N?
Well, a positron, I think. If it isn't a positron the antimatter particle of an electron, so if they bump into each other, poof. But they don't vanish into nothing. They'll just change into a different energetic form. So conservation of energy is obeyed,
Yeah.
So if you had an antimatter universe that bumped into our universe, let's say our universe is mostly regular matter, then the two would cancel each other out, but then you'd be left with like a sea of particles or something. You wouldn't have non-existence emerge or something. Because then you'd have, probably a lot of students are always familiar with Einstein and those chaps they talked, back then, early quantum physicists talked about conservation of energy. Energy can't be created or destroyed. So, often people get so mystified by the idea of antimatter. Wow. It's pretty hot stuff, huh? No, it's just a kind of particle, okay? If you go in your chemistry lab and study a particle, and you can detect it, and you can see it on your computer screen, a little dot shows up where it hits the panel in the back of the lab. It has a certain kind of set of properties to it. Well, if you can discover the antimatter particle to it. It just is the opposite particle called the positron. So people often think antimatter is like a different world, or spooky, spiritual, cool stuff or something. But no, it's just another set of particles. It kind of reminds me of when people talk about imaginary numbers in mathematics. People think, oh wow, that must be something pretty mysterious. No, it's just another number plane. You've got the x, y, and the I plane. So it's just another plane of numbers. There's nothing mysterious. But scientists are just not very good at naming things, which is what's going on here. Big Bang. I guess that's kind of good. But it wasn't big, and there was no bang. Is the problem. Yeah.
Where was this guy from?
Greece, ancient Greece. Okay, so these all these philosophers will be ancient Greece for a while until we get to some of the medieval Christian philosophers. Okay, so here are some similar types of ways you can think about this paradox, and it makes stuff up that's not it. There's the paradox right there. Here's another way to think about it. What if you had items that don't have size that make up things that do have size? What if you have items that are immaterial, which make up things that are immaterial? Oh, you've already seen that one. That's right here. Okay. What if there are items that are timeless that compose time? Now, I don't say it here in these notes. I'm just giving you examples of how this paradox, the anaximander, how different ways it could be labeled. But the reason this is here is because these are the present-day versions of this paradox that anaximander was the first one that we know of to start talking about. And so if you go to your chemistry professor or your physics professor and say, is it the case that a lot of physicists hold that the little building blocks that make up everything have no size at all? And they'll tell you, yeah, about half of them. That's called the standard model, or the standard interpretation of quantum physics. And then you could say, well, how do the teeny things with no size make up things that have size, like the table? And they'll say, go talk to the philosophy department, is what they'll say. So same thing, like look at this one. Particles don't exist in time, okay? Particles that have been discovered in science are like mini black holes. What's called a singularity. If you don't understand that term, don't worry about it. I'm just going to discuss it quickly. These things don't exist in time. So, and there's other ways to think of time not existing in the micro quantum realm. So how do they compose things how do they compose a reality filled with motion and time? So there's some big disconnects here. So it kind of brings you back to these three options over here. This one's starting to look kind of good, huh? So you have to wait on that one until we get to play out. Well, we'll study it a little bit before that, but it'll come up a lot. So so the same problem as the modern versions of the paradox exists for apeiron. Apeiron is the nature not n, but composes objects that are n. Or it can be anarchimetically, it can be the opposite. So it can be the opposite. Apeiron can be n, and compose things that have none. So clearly what he's trying to describe is a magical thing that makes up everything. And there's good, like I said, just to repeat, there's good reason he said that because that appears, even in the modern scientific context, appears to be what's needed. You got something that's really bizarre that, in other words, if you can crunch down anything into its smallest pieces, like this piece of chocolate, smash it into bits and keep breaking it down, till you reach the final particles, those particles are going to be very different than anything you're familiar with in your everyday life. Okay? Yeah?
Is there any etymology behind the word apeiron, or?
Oh, not that I know of. It's supposed to mean chaos or void or mystery. A lot of these Greek words like logos, we'll be talking about that word, are, they'll have all different kinds. Nobody really knows how to translate them. They clearly go to some kind of paradigm or ideology from way back that we just have different labels people give them. Like logos, which shows up in the Bible, that one, does it mean sound? Does it mean logic? Does it mean God? It appears to mean a lot of those, all those different things. So, so good question. So here I think I'm describing the paradox again here. How can apeiron compose all of reality when reality contains items with opposite properties? If apeiron composes things with X properties, how can it also compose things with non-X properties? This poses a serious problem. How can apeiron compose things devoid of apeiron-like properties? Yeah, so saying the same thing in different words. So here we go. This is also a problem today. The three paradoxes listed above, these right here, you can go talk to your chemistry professor or physics professor, they'll tell you all about it. Okay? And they'll have a lot of interesting things to say about it. There's people trying to invent theories of the basic building blocks to make it look like this. Anybody know an example? It's a real famous one. One's called string theory. Some of you heard of that? Yeah. It's on PBS every other night, and Discovery Channel and stuff. Does anybody know how much evidence there is to support string theory? It's a very precise amount. Zero. Exactly zero. If something is wrong, all it means is it's just a mathematical theory at the moment. It could be, shown to be correct in the future. I don't think it will be, but, I'm just a philosopher. What do I know? So, all right, if anybody has any questions, just stop me, or else I'm going to keep going if you don't, though. So perhaps Anaximander was attempting to avoid serious dilemma by asserting that apeiron that makes up reality ultimately must consist of some sort of infinite stuff. There's another translation. Sometimes it's called infinite stuff, which means magical. Because how can you have an infinite thing? Usually the word infinity is used in two ways, like supernatural. Another way it's used is to say it's there's a collection of things that are so numerous there's no last, you can count forever. There's no last element that you can count. Either way, you're talking about something that breaks physical laws. It's magical. Yeah?
Can you do like a quick summary of string theory?
Oh, of string theory? Yeah. That's a really big deal in science right now, even though it's completely devoid of any science whatsoever, because it's just a mathematical theory. The quickest, bare bones way to sum it up is to say, instead of, if something's non-physical, what are the sizes of basic building blocks? Zero size. They're the size of it. Remember geometry? Yeah. Like the point makes up the line. Mm-hmm. So the zero dimensionality makes up the one dimension. And nobody ever raised their hand and said, excuse me, Mr. Herbert, or whatever the hell your geometry professor or teacher's name was in freshman year in high school, how does something with no dimension create something with one dimension? And they'd say, but you'd have a good, that's what we're talking about. That's the problem. That's what exists in contemporary science today, that paradox. So if you say something is zero size, then you're saying it's non-physical. Okay, so what you say over here is you get rid of that issue, for example, and you say, no, the fundamental items have some kind of dimension that's non-zero. It's one-dimensional or two-dimensional. It's like two-dimensional would be a sheet. One-dimensional would be a line. And that's what mathematically, a lot of people are trying to take what is known from science and go further with mathematics and get to the point to say that no, if we look further into things, we can't do it with observations yet because we don't have big enough microscopes, so to speak, the big accelerators that are all over, to investigate all the little basic building blocks. But if we do it mathematically, we can get to the discovery that they actually do have some kind of size. So therefore, which is called string theory. So you invent this idea that basic building blocks either look like something like this, little loops and stringy things, or they look like sheep, like that. So two-dimensional or one-dimensional. Okay.
So it's not only a line.
Pardon?
So it's not only a line.
Yeah, a line or a sheet. It started off, most people think of it as a line, like a string, because that's what it started off at, but then it turned into what's called M theory. And that's just a variation which you thought of membranes, which are these sheets. But, good luck with that. I mean, how do you have something waving around like a string that's not made of parts? Right? If it's made of parts, then what are the parts? Well, they're going to ultimately reduce down to being points, zero size. So, I don't know. To be honest, I don't know all the math, but when I was in graduate school getting my master's degree, I happened to be really lucky to work with this philosopher who knew a ton about quantum physics, and he told me that this idea of one and two-dimensional stuff was just invented. What people did, they just created the equation to make the dimension part of the equation be not equal to zero. And I've read that in a couple of those popular science books you can get at Barnes & Noble and stuff. I almost said Borders, but after them. So that's the simplest way to describe it. And then after that, there's 10 zillion different directions this has gone. When you have pure theory without observation, you're going to get a huge mess of theories going everywhere, and nobody really knowing what the hell's going on. That's exactly what the string theory is today. If you doubt that, go ask your physics department, and they'll say, yeah, that's pretty much what's going on. That make sense? Yeah, that's the simplest way to put it. Okay, so yes, I'm going to skip this last paragraph here, and we're going to go on to, oh yes, we're already at the atoms. Good. So I already got that. I went through that anti-matter intersection, but I'm skipping this paragraph, so you don't need to worry about it for the quiz. It has to be up here on the screen. I have to read it for there to be a quiz, okay? Or if I don't, then it's not on the quiz. All right, so now let's talk about, we've been talking about basic building blocks. And there were a number of philosophers in India, and two, Philosophers and Democritus, we're going to say Democritus right now, in ancient Greece, who discussed the philosophy of atomism. Okay? So let's get rid of all this. So we've got this diagram that I drew, which is getting used quite a bit. So here's the tiny domain, and here's the, everybody know what the word macroscopic means? Word you should probably get used to in this class. Macroscopic just refers to a level of reality. You ever think about how reality comes in levels? If you look out into space, everything's huge, so there's a level of reality. Huge. Or if you look into that teeny stuff in the microscope, things get really, really tiny. So, the tiniest would be the stuff that makes up everything. So there's a tiny level. And then right in the middle, we call the macro, the macroscopic. This is basically at the level of things that you can see and interact with. If you're a blind person, you feel and interact with, or hear and interact with. The things that your senses pick up. Okay? So would a cell in your hand be huge? No. Macro? No, because you can't see it unless you have the aid of a microscope, let you see something tiny. So would a star be in here? Kind of right in the borderline. But how about a humongous set of galaxies? You ever know what a galaxy is? That's a collection of stars out in space. Ours is called the Milky Way. That would be not macroscopic. That would be called Okay, so what Democritus here, you notice how over here when we were discussing string theory, we were talking about, if a string is waving around like this, seems like the only way to do that is if it's made up of parts, right? Well, you could apply that to anything. If anything's moving around, like look at this piece of chalk. Actually, I'll break the little one, small one. That's too small to break. See this? If I can, now it's one whole item. Now it's two disconnected pieces. Okay? The only way it seems that we can describe interactions like that is if we develop this idea that everything is made up of tiny little pieces. Okay? So everything physical, and we'll talk about this in the notes here, I think. Everything physical is made of tiny pieces. Okay? Because if not, how could there be motion? If there were no pieces, and there was just one block of stuff with only one thing, well then you couldn't have anything moving around, no motion or anything. Okay, so, well then it leads to another question. If everything's composed of tiny little pieces, let's say, here's a piece. It's got, here's a right half and a left half. And you can break it apart then, it seems like that thing, as long as it's something that has size to it, some magnitude, it seems that you can break things apart. So where do you stop breaking things apart? We'll discuss that shortly, but these are some of the questions that Democritus was getting to. But what Democritus thought was, you can't break things down so far that they have zero size. Why did Democritus say that? Because that leads to this paradox. This is exactly what Democritus, the ancient Greek philosopher, what were his years again? 460 to 370. I should know that by heart, but not good with I know general dates, not specific dates. So what Democritus wanted to say is, okay, you have to have pieces. Everything has to be composed of pieces in order to have motion. And you have to have the pieces must be non-zero in size. Okay? So he's talking about position 2 over there. But there's a third issue, which you're going to see in these notes here in a second, is the pieces can't have parts. Sorry, we're talking about the ultimate pieces. All right, and when you get to a final level where you can't cut the pieces apart anymore, they can't have parts. They have to have size. And well, yeah. So now that leads to an obvious problem, which we'll be discussing here in a second. How can something that has a size not have parts or pieces to it? Because, like we said, doesn't this have a top and a bottom half? Well, there's 2 parts. Are those just our imagination? Where we think about it having parts, it really doesn't have parts? Those are the questions. If you could discover atoms in the way Democritus was discussing long ago, then you would verify this point right here. All the paradoxes and stuff we were talking about before go away. Yeah?
I'm just wondering how you came up with the name atom.
To my knowledge, and I'm not a language dude, this is just from reading some stuff on the side. You're like Adam, first man, sounds like Adam. And then there's Atman. Anybody Hindu in here? No? Okay. Atman means, it's sort of like the first principle of what a human is, like your soul, irreducible atom, that what you are. And that it seems like there was this theme back then in India and Greece and in those parts of the world where words that had this sound meant, like they refer to something to do with, primary stuff, fundamental stuff that makes up everything. So that's as much as I know. There were words like the first man, his name Adam, the first piece of reality is called atom. Sometimes it's spelled like this, apparently. You have to have the language department. Apparently, originally it looked like that. Atom. There's There's no tone means part, I guess, and there's none, so non-parts. I don't know. Stuff like that. It was just some language being thrown around then. Yeah?
Don't atoms have parts?
Oh, okay. We will discuss, I think, pretty quick here. I don't know where it comes up in the notes. You all have to you have to think about atoms in two ways in this class. One, scientists talk about atoms. What we call those in this class is scientific atoms. And those have parts, as you're saying. Well, some of the parts, electron, nucleus, blah, blah. Now, but philosophers, we talk about atoms also. But you can call the atoms we talk about philosophic atoms, and they have no parts. Okay? So why this is confusing? Was somebody drunk or something that invented all this crazy language? No, here's what happened. The scientists messed up. I think it was J.J. Rutherford, 114 years ago or something. Everybody was looking for the atom. You know, the fundamental thing that has no parts, that makes up everything. Back in the day. And over the last couple hundred years. And scientists thought they discovered it, okay, from about 1850 into right around 1900. And so people started calling this unit of nature the atom, and it really stuck. But guess what happened? Say here's the atom right here. People started noticing stuff shooting out of it, and they called those electrons. And people started saying, well, if you stuff shooting out of it, it's not an atom. It doesn't have parts. It has parts. Okay, but it was too late. The word already stuck. So what scientists refer to atoms is a certain level of nature, but it's not the fundamental level. That's why scientists developed this word called subatomic, below the atomic. And philosophers, well, we still use the old word, because they think that other parts are atoms. So that makes sense. So there's two ways the word atom is used in science and philosophy, and they're almost the opposite way. So you have to remember that. I'll help remind you. If I forget, let me know. But that's the issue. Yeah?
So the philosophical atom is smaller than the...
Yeah, the philosophical atoms will compose the science's atoms.
Okay, so there's philosophical atoms that make up the electrons, and there's other philosophical atoms that make up the neutrons.
Some people think the electron is a philosophic atom. I don't, because it's got stuff shooting out of it too, pieces of light, namely. But yeah, some scientists think that electrons that we actually discovered them. They're making the same mistake again. They're saying, but yeah, if we find something, which I think we will sometime, I don't know when, which truly has no parts, then the atoms that some of the early philosophers originally talked about, those will be the actual atoms. Did you ever tell me about this?
Oh, I was wondering, so then, like, atoms in science aren't the fundamental?
No, they have you can break them down into smaller bits, like quarks is one thing, little smaller pieces. Like you almost think of them like a molecule, just slice them up, smash them up. Yeah.
How can you find something that doesn't have parts?
Do you know a guy named an actor named Mark Duplass? Okay, look him up. You look exactly like him. Anyway, go ahead. Sorry.
I don't get how you could find something that doesn't have parts.
Oh, well, it would seem that it would look like this, right? And if it did, how do you see it? You can't. This is invisible. The only things we can see have a surface. They have a non-zero side. So the only way you could possibly, there's a couple ways you can think about discovering them. If they interact with each other, if zero-size items, true atoms, philosophic atoms, interact with other things, if you detect their existence that way, you have to do it in those kinds of ways. So in other words, if you could shoot particles into a tank of other particles, like a tank of helium, doesn't make a wake like a boat does through the water. You can try to measure how particles behave in those ways and stuff. So yeah, it's tricky. Nobody ever sees atoms. You just see it, what your computer tells you is going on with them. Okay, so let's start reading some of this here. This is kind of where we're going. So the pre-Socratics are largely concerned with the makeup of reality, as you can tell. What makes up everything is what they want to know. So as your textbook says, the pre-Socratics sought the basic ingredients of the world we live in. Yeah, so here's the pages for Demosthenes. pretty good stuff in the textbook about that. So there might be fundamental things in the universe that are responsible for making up everything. Some of you are wondering, why do we have to have a final level? Why can't we just divide and divide forever? We're getting there. That's not where these, well, we're kind of, yeah, we'll get there. So perhaps we could find these elemental things if we cut some random object apart so we couldn't cut any further. This is called atom. So here's what the idea of atomism is. Philosophy of atomism. There are fundamental basic building blocks or atoms which are partless objects that do not have any parts that make up everything in the universe. Okay, so I think all of you are kind of picking up on this before I even read that, but there's our formal definition. What's the footnote there? Okay. So, yeah, Democritus is the philosopher who's kind of, a lot of people are like, hey, he discovered the atoms of science. I mean, I've heard this so many times. I have people find out that I teach philosophy and they'll say, oh yeah, wasn't there a guy in ancient Greece who discovered the atom? And the answer is no. Clearly no. Because he was talking about partless things, and the contemporary scientists, what they call atom, totally different, right? It has parts. Okay, so here's what your textbook writes about Democritus. Democritus' fundamental thesis. Can you push that door close? Thanks. Democritus' slam it. Just kidding. It'd be kind of funny if they'd be like, oh no. Or else they'd be like, who cares? So Democritus' fundamental thesis is that matter is not infinitely divisible. Okay, yeah, so that's, some of you are wondering, okay, if we can take something and crunch it up into little pieces, why do we have to stop? Why can't we just divide forever so there are worlds within worlds down into the smaller and smaller levels? And maybe even if you get bigger, you can have worlds and worlds forever. Maybe our universe is just an intermediary step between infinite smaller worlds and infinite larger worlds. So this debate now is going to start in ancient Greece in the 400s, the early 400s and late 300s with Democritus. And it continues with Aristotle, and it's still going on today, big time. Philosophers are publishing professional articles all the time. I've published a couple on this very topic. You know, how do we know there are atoms or not? Why can't we, whenever we think we run into something that's partless, maybe it's just that it just looks that way and maybe it actually has parts you can divide it up more. So, but Democritus did not go there. He rejected the idea that things are infinitely divisible, for reasons we'll discuss shortly. So yeah, we don't know exactly why he held that conclusion because we only have about 60 or so of his statements. I think your textbook gives a couple. Aristotle tried to, why don't I read this? This is kind of metaphysical. Okay, I'll just do it quickly. Here's what Aristotle discussed, he liked and discussed Democritus quite a bit. Aristotle is a very famous philosopher that comes along about 100 years later. And what he said was, yes, we have a reason to think that you can't keep dividing reality, dividing matter into smaller and smaller pieces. You have to stop at a certain point. And I think this is what we're going to discuss here. So let me continue here. So if we take a chunk of any kind of stuff and divide it up as far as we can, we will have to come to a halt at tiny bodies that are indivisible. We cannot allow matter to be divisible to infinity, for let us suppose that the division has been carried out, and then ask what would ensue if the division was carried out. If each of the infinite number of parts has any magnitude, then it must be further divisible. Okay? Which contradicts our hypothesis. If on the other hand the surviving parts have no magnitude, then they can never have amounted to any quantity. For 0 multiplied by infinity is still 0. So we have to conclude that divisibility comes to an end, and the smallest possible fragments must be bodies with size and shape. So what Aristotle is just trying to do is avoid this. That's what he's really doing. Okay. Because what he's saying here is that reality doesn't make, if some of you kind of starting to pick up that this whole thing doesn't make any sense, right? In other words, if we pick up a piece of chalk, start smashing it and cut it in half, keep cutting it and cutting it and cutting it and cutting it, you run into paradoxes, okay? Can we cut forever? So there's infinite worlds inside of a piece of chalk? I guess that could be possible, but it just entirely paradoxical to our common sense thinking? Or is it the case that you can slice it down where eventually you reach the non-zero size part, which leads to, well, this isn't just a paradox, this is a direct contradiction right there. Or do you run into small building blocks that do have a size, which is what Democritus is talking about, but that has paradox. Okay, what's the paradox with it? You have something that has size but doesn't have parts. Mega paradox. So everything's starting to get to be a huge mess. And some of you are thinking, that's because we don't have the proper understanding of what's going on down there. And that's very possible that that's all is the case. But something mysterious seems to be going on. Yeah?
So is it sensible to assume that, like, mathematicians believe that you can, size is like infinity and that you can always cut it down to, like, half its size? Because, I mean, numerically it could be point and then have, like, 0 to, like, be 100th exponent, but it can still be divided by 2, like everything.
Yeah, if you've got an atom like Democritus was talking about, so something that would fit into here. So it's some, say it looks like this. Okay, there it is. Because he likes to say they have hooks and stuff, that's how things latch on each other, that's what the philosopher Democritus would say. So this would have to be what's called seamless. It means it has no, or what's called an undifferentiated whole. That's kind of hard to explain here in Intro Philosophy 100. This is what Hindu philosophers talk about a lot. Undifferentiated oneness. And that just means that this thing looks like it has extension, but it's only one thing. So if you look at this little part of it here, that is indistinguishable from this part over here, which are both indistinguishable from the whole thing. That's the kind of message you run into when you start talking about atoms that have a size. Partless, fundamental pieces of reality that don't have parts, okay, but which have size. So it gets to be a huge mess. You see what I mean? Really? Okay, good.
No.
Good. Well, yeah, I mean, do you see what I mean by it doesn't make sense, or do you not understand anything I just said?
I don't know.
Okay. I mean, either. Yeah, this all turns into, I mean, imagine if you had a thing right here, if they were holding something that looked like a sphere. And I said, this is a single atom that has no parts at all. Okay, so if you look at this little part here, the little part there, all you can consider it is one thing. So only can you consider so it would actually be, if you wanted to consider like this little top piece right there, that would be illogical. Because there is no such thing as just this little piece. You only can consider it as one undifferentiated thing, which has no seams, no creases that you can split it up at and stuff. But that doesn't make sense, because why can't I just consider it to have like a little top piece right there? So the idea that the atoms that make up everything have a size, an extension that is, but no parts, runs into. So everything's running into paradox. Okay, and that's what Aristotle is doing, is he's just trying to say, well, I don't think this paragraph here, you won't have to know this for your quiz, okay, because your textbook is going through it, and it would take me a long time to discuss exactly what's being said. So I think we'll leave this specific paragraph off. Everybody got that? So the quote from your book, the textbook on page, that's quoting your notes on page 27, if you have to know. But what Aristotle's saying is you never can reach the end of divisions because there's infinite steps, and you never reach the end of infinity. So what you have is you never can divide everything up. So you've got little atoms that are indivisible, that have some kind of size. Do we go to 50 or 55? I forgot. 50, okay. I'll find the other semester you also was really 55. Just kidding. So I got 3 more minutes, so I'm going to keep going here a little bit. So here's an interesting point. The very debate whether the basic building blocks, the true philosophic atoms, the things that make up everything, whether they have a size or not, in other words, whether they have an extension or their point size, they're unextended, this is still a major issue debated all over the place today. In fact, if I'm basing your question, which I'm glad you asked now, because let us refer back to this is the fundamental difference between the 2 major branches of contemporary science, quantum physics, that studies the basic building blocks. One is called the Standard Model of quantum physics, and they assert that the basic building blocks have no size, and then this ensues. And then there's the string theory. That's the other big group. There's some other groups too, quantum gravity theory, blah, blah, blah. But this is the other major group, and they hold no that they have some kind of size. So the same debate is going on. So you can kind of ask, have humans really learned anything in the last 2,400 years? And the question is, I don't know. When we get to, if we study a philosophy called postmodernism this semester, that's a group of philosophers that say, no, humans haven't learned anything. We never knew anything. And this is a good illustration of why. We're talking about the exact same debate. We've been able to learn how to use and manipulate matter so we can build cool stuff, like TVs or bombs or whatever the hell people are building. But we don't really understand big picture stuff. Who am I? What is reality? Stuff like that. So, so this is the same debate, still goes on today. The standard model of quantum physics involves the idea that the basic building blocks, the philosophic or true atoms, are points, and the other is string theory, where they have some kind of extension. So this is as far as I'll get here, right there. So I think I skipped a couple parts. Some people are leaving early.